Let's look at adding polynomials next. Whenever you're adding polynomials, you must add each pair of polynomials by combining like terms. This means that you can't combine terms that don't look similar. The leading coefficients can be different, but the terms itself must be similar. They must be the same. So if you have 3x squared plus 4x plus 5, and you have negative 2x squared minus 8x plus 3, notice that I've stacked these vertically based on the degree and the letters or variables involved. Since 3x squared and negative 2x squared both have matching variable and degree, I can combine their leading coefficients, the numbers in front. Similarly, with 4x and negative 8x, they both have an x to the first power in common, and so I can combine their leading coefficients, 4 and negative 8. And lastly, I have 5 and 3. Well, those are just numbers, and those are pretty easy to add together. We've been doing that for quite a while. So I'm just going to add these down. 3 minus 2 will give me 1, and my term variables was x and squared. 4 minus 8 is negative 4, and the x is my variable. 5 plus 3 is 8, and so I've completed that simplification, or that sum. I'm going to do something very, very similar on the next one. I'm just going to highlight them similarly to the previous one. I have an a squared and an a squared. I have a b and another b. I have an ab and an ab term. And then lastly, I have a 6 and a negative 2. What I'm going to do is look at the leading coefficient. If it's just a negative, it's assumed to be a negative 1a squared. So we have 3a squareds minus 1a squared gives me 2a squareds. I have a negative 2b and a positive 5b. That gives me a positive 3b. I have a plus ab and a minus 5ab. That gives me a minus 4ab. I have a 6 minus 2, which will give me a positive 4. Color coding wise, I have an a squared, I have a b, I have an ab, and I have a term with just numbers in it. And I'm done. Let's look at this last one here. We have some different terms that we need to identify. We have an xy and an xy. We have an xy squared and an xy squared. And lastly, we have an x squared y and an x squared y. Some of you might be thinking, well, they're all the same variables. The exponents just changed, and that is correct. They did change. And as soon as a variable has a different exponent on it, it's no longer a like term. So you have to make sure that both the letters and the exponents match before you can call them a like term. So I'm just going to write 2/3. And remember, I'm adding, but this is a minus 4/5, so minus 4/5. And these are both xy terms. I have a 5/6 xy squared and a 3/4 xy squared. And I also have, and by the way, that's a plus here. So I'm stacking the like terms. And then I have a 5.1 x squared y and a minus 3.4 x squared y. So now I just combine them. I'm going to add them up vertically. Now you could do this in your calculator, and if you're not really super comfortable with fractions, please use your calculator. I don't want you to lose points just because you don't remember how to add fractions. So do 2 divided by 3 minus 4 divided by 5. Hit enter. Do not give me a repeating decimal. If you can just get past the repeating decimals and you can give me an exact fraction, all your teachers from here on out will appreciate it. Click on Math and then hit enter to reduce a fraction. So that frac means you're going to take the answer you just got and reduce it. The combining of 2/3 and 4/5, if you combine those two, you get negative 2/15. That's 2/3 minus 4/5. So my exact fraction is negative 2/15. X, Y. Now let's take 5/6 and add 3/4 to it. That's 1.58333 repeating. Again, math, frac, enter. That's 19/12, so plus 19/12 xy squared. Now let's take 5.1 minus 3.4 equals 1.7. Now since this was given to me as a decimal, I'm going to give a decimal right back. So plus 1.7 x squared y.